How big is Andromeda? Tonight, we drift gently into the quiet of space, far beyond the familiar pattern of stars in our night sky, far beyond the soft band of light we call the Milky Way. There is another great island of stars. It is known as the Andromeda Galaxy. Andromeda is not close. It rests at a calm and steady distance from us, so far away that its light takes millions of years to arrive. Yet even from here, even across that vast stretch of darkness, it can be seen as a faint glow on a clear night, a soft smudge of light, quiet, unhurried. When we speak of Andromeda, we are speaking about something so large that the mind does not easily hold it. Its size is not like the size of a mountain or a planet or even a star. It is the size of a galaxy, and that is something much, much larger. As you settle in, imagine floating gently outward from Earth, not rushing, not traveling quickly, just drifting. The Earth becomes smaller beneath you. The moon rests nearby. The sun glows calmly in the distance. Beyond the sun are more stars, thousands, millions. They are all part of our own galaxy, the Milky Way. And beyond that, in the deep quiet of space, lies Andromeda. It stretches across space in a slow spiral of light, wider than our own galaxy, yet so distant that it appears as only a faint glow in our sky. Its size is difficult to imagine, so we will imagine it slowly. We will approach it gently. We will think about its width, its stars, its quiet shape, and the way it rests in the vast stillness of the universe. And we will do so in a calm and steady way, allowing each idea to unfold softly. A galaxy is not a single star. It is not even a small group of stars. A galaxy is a great gathering of stars, dust, and gas, all moving together through space. Our sun is just one star among hundreds of billions in the Milky Way, and the Milky Way is just one galaxy among many. Andromeda is another galaxy, a neighbor in cosmic terms. Though even that word, neighbor, feels gentle compared to the true distance between us. Galaxies are like vast cities of light. Each star shines quietly, separated by enormous distances, yet all bound together by gravity. They move in slow, graceful patterns. From far away, a galaxy can look like a soft swirl, a spiral of light turning slowly around a bright center. Andromeda is such a spiral galaxy. It has long arms that curve outward from its center, wrapping around like a calm whirlpool made of stars. These arms are filled with countless suns. Between them lies dark space, not empty of meaning, but spacious and still. When we think of size, we often think in miles or kilometers, but galaxies are measured in light years. A light year is the distance light travels in 1 year, and light moves very, very fast. It circles the Earth many times in just 1 second. And yet, even traveling at that speed, light takes over 2 million years to reach us from Andromeda. That means the light we see tonight left Andromeda long before humans built cities, long before written history. It has been traveling calmly through space, uninterrupted, steady, and patient. And that is only the distance between us. The galaxy itself is even wider. Andromeda stretches across about 200,000 light years from one side to the other. 200,000 light years. If a beam of light started at one edge of Andromeda and traveled straight across to the other side, it would take 200,000 years to complete that journey. That is how wide it is. To imagine this, we might first think of our own galaxy. The Milky Way is about 100,000 light years across. Andromeda is roughly twice that width, twice as wide. Not crowded, not rushed, just vast. Imagine standing at one edge of Andromeda, not on a planet, not near a star, but simply imagining yourself at the outer boundary, Before you lies a soft spiral of light stretching across unimaginable distance. You begin drifting across it. Years pass. Centuries. Millennia. Light itself would still be traveling. The stars inside Andromeda are not packed tightly together. Even within a galaxy, the distance between stars is immense. If our sun were the size of a small marble, the nearest star would be many kilometers away. So within Andromeda, though there are hundreds of billions of stars, there is also extraordinary space between them. Space that is calm. Space that is mostly empty. Space that allows each star to glow quietly on its own. Andromeda contains perhaps 1 trillion stars. 1 trillion. That number is so large it becomes gentle in its meaning. It is beyond everyday counting, beyond stacks of numbers on a page. If you tried to count 1 star every second, it would take more than 30,000 years to count to 1 trillion. And that is how many stars may be in Andromeda. Each of those stars may have planets, some large, some small, some warm, some cold, worlds circling quietly in distant orbits. Yet from here, from Earth, all of, that becomes just a faint glow. The reason it looks small is because it is so far away. When you hold your thumb up to the sky, you could cover Andromeda with the tip of it, and yet your thumb is tiny compared to the sky. Andromeda only appears small because of distance. Its true size remains immense. If it were closer, if it were at the distance of the moon, it would fill the sky from horizon to horizon. It would stretch wide overhead, a vast river of light arching across the night. But distance softens it. Distance makes it appear gentle. And so it rests in our sky as a quiet blur. The more we think about its size, the more we return to the idea of width. 200,000 light-years across, a spiral stretching through darkness. Its central region is dense with stars, glowing softly. Around it, its spiral arms extend outward, thinner, more delicate. Beyond the visible arms lies a halo, a faint spherical region containing even more stars and clusters, extending far beyond the bright disk. So when we speak of Andromeda's size, we speak not only of its bright spiral, but also of this extended halo, a larger, quieter boundary. Its gravity reaches far into space, holding its stars together in slow motion, all of it turning gently, all of it steady. If we imagine shrinking ourselves to the size of a single star within Andromeda, the galaxy would still feel endless. Stars would be scattered across vast darkness. The nearest neighbor would be far away. And yet, taken together, they form a single graceful structure. This is how large Andromeda is. Not large in the way of a towering building, not large in the way of an ocean wave. Large in a quiet way, large in a way that stretches across time. Because size in space is also linked to time. When we look at Andromeda, we are seeing it as it was millions of years ago. Its light carries history within it. The stars we see shining in its glow have been shining for ages. They move slowly around the center, completing one orbit in hundreds of millions of years. Nothing rushes, nothing hurries. Andromeda is vast, but it is also patient. If you imagine drifting closer now, gently crossing the millions of light years between us, Andromeda would slowly grow larger in your view. The faint smudge would become a disk. The disk would become a spiral. You would see lanes of dust tracing soft curves through the arms, regions where new stars form quietly from clouds of gas. And still, there would be space, vast space between each light. Even with 1 trillion stars, most of Andromeda is emptiness. This emptiness is not frightening. It is peaceful. It allows the galaxy to breathe. The stars are like distant lanterns suspended in a dark, open field. And so, when we ask how big Andromeda is, we are asking about something that cannot be held in the hand. cannot be walked across, cannot be circled in a lifetime. It is 200,000 light-years wide. It contains perhaps 1 trillion stars. It is over 2 million light-years away, and yet it sits quietly in our sky, patient and calm. From Earth, we see it with telescopes as a graceful spiral. Through long exposures, its structure becomes clear. Its arms extend far beyond what the eye alone can see. Still, even the most detailed images cannot truly convey its scale. Because scale in space is not only about width, it is about perspective. If our entire solar system were placed within Andromeda, it would occupy a tiny speck inside one of its spiral arms. Our sun would be one star among many. Not at the center, not at the edge, just one light in a vast collection. Andromeda's center contains a dense concentration of stars. At its heart lies a supermassive black hole, quiet and steady. But far from dramatic, it simply rests there, influencing the stars nearby. Around that center, stars orbit slowly, tracing paths that take hundreds of millions of years to complete. Imagine a star beginning its orbit when dinosaurs roamed Earth. By the time humans appear, it would still not have completed a single revolution around Andromeda's center. This is the timescale of a galaxy, wide, slow, steady. As we return to its width, let it settle gently in your mind. 200,000 light-years from edge to edge. If you could travel at the speed of light, the fastest possible speed in the universe, it would take 200,000 years to cross it. Even light must be patient. Even light takes time. And so Andromeda is not just large in distance, but large in duration. It has existed for billions of years. Its stars have formed, aged, and gently faded. Yet its overall shape remains graceful. From Earth, under dark skies, Andromeda can be seen without a telescope. It appears as a faint, elongated glow, soft, barely there. And yet, that faint glow contains more stars than we can imagine. This contrast is soothing. Something so immense, appearing so small, something so distant, yet visible. It reminds us that perspective shapes our experience. If we step back farther, drifting beyond both the Milky Way and Andromeda, we would see them as two spirals in a larger sea of galaxies. Andromeda would still be large, larger than the Milky Way. Its disk slightly wider, its star count slightly greater. But even then, it would be one among many. The universe itself contains billions of galaxies, each vast, each slow, each steady. And in that wider view, Andromeda is large, yet also part of something even greater. As you continue to rest, imagine Andromeda suspended in darkness. Its stars glow gently. Its spiral arms curve like soft brushstrokes across a canvas of black. The distance between its stars is immense. The distance between it and us is even more immense. And yet it is calm. It does not rush toward us. It does not demand attention. It simply exists. Wide, quiet, steady. If you could float within one of its spiral arms, you would see stars scattered across the sky in all directions. Some brighter, some dimmer, nebulae glowing faintly in pink and blue hues. Dark lanes of dust stretching like shadows between lights. But even there, you would feel space. Open space. The nearest star might still be trillions of kilometers away. Galaxies feel crowded only from a distance. Up close, they are spacious. This is another gentle truth about Andromeda's size. Though it contains so many stars, there is room between them. Room for light to travel. Room for calm. Room for silence. When astronomers measure Andromeda's diameter, they use the faint outer regions as well. The bright disk is only part of its true size. Its halo extends much farther, containing globular clusters and faint stars orbiting at great distance. So even the number 200,000 light-years is an estimate. Some measurements suggest its outer halo may stretch even farther. But whatever the precise number, the idea remains the same. It is vast. Vast in width. Vast in star count. Vast in time. And yet, from Earth, it appears gentle. A soft glow. A quiet neighbor across the darkness. Now imagine lying on Earth under a clear night sky, looking upward. The air is cool. The stars are scattered like grains of light across black velvet. Among them, Andromeda rests, faint but steady. The light reaching your eyes tonight began its journey long before human civilization. It traveled through intergalactic space, uninterrupted, moving at the fastest speed possible. And still, it took over 2 million years to arrive. That journey itself speaks of distance. It speaks of scale. It speaks of quiet endurance. Andromeda does not change quickly. Its stars move in slow arcs. Its structure evolves over billions of years. Nothing sudden, nothing sharp, just gradual motion. If you imagine time speeding up, you might see its spiral arms turning gently, like the hands of a clock moving too slowly to notice in a single lifetime. But we do not need to speed up time. We can simply rest in the awareness of its size. 200,000 light-years wide. 1 trillion stars. More space between those stars than the mind can picture. And all of it suspended in the quiet of the universe. As this thought settles, let it soften. Let the vastness feel spacious rather than overwhelming. Because in space, vastness is peaceful. There is no noise in the vacuum between stars. No wind, no rush, only silent motion. Andromeda continues its slow rotation. Its stars shine steadily. Its light travels patiently across millions of years. And here on Earth, we glimpse it as a small, calm glow. The largest things in the universe often appear the smallest from far away. And that is a comforting perspective. Size depends on distance. Distance softens edges. Distance makes even a galaxy feel gentle. As we move toward the end of this quiet journey, return again to its width. Imagine drawing a line from one edge of Andromeda's disk to the other. That line would span 200,000 years of light travel. Imagine standing at the center and looking outward toward the farthest star in its halo. You would see faint lights scattered across darkness, stretching beyond the bright spiral. Even at that distance, gravity holds them gently in orbit, everything bound together in slow harmony. Andromeda is large, yes, but it is not loud. It is not hurried. It is simply wide, simply full of stars, simply steady. From Earth, we see it as it was long ago, and long from now its light will continue to travel outward, reaching distant observers across the universe. Galaxies endure for billions of years. They rotate calmly. They glow softly. They remain. Now let the thought of Andromeda's size become softer still. 200,000 light-years, 1 trillion stars, millions of years of light travel, all of it moving quietly, all of it steady. As you drift towards sleep, imagine Andromeda resting in space. No rush, no urgency, just a wide spiral of light turning slowly in darkness. Its stars shine gently. Its arms curve gracefully. Its motion is calm. And though it is unimaginably large, it feels distant and serene. The universe is vast. And within that vastness, Andromeda rests, wide, silent, steady. Let that steady motion become your own slow rhythm. Let the idea of distance become spacious and calm. Let the size of Andromeda feel like an open sky, stretching endlessly, yet gently above you. Everything in space moves slowly. Everything in space has time. And so do you. Andromeda continues its quiet rotation. Its stars continue to glow. Its light continues to travel. And here, on Earth, you rest beneath it. Small perhaps, but part of the same vast universe. Drifting, breathing, calm. The galaxy is wide, the night is quiet, and everything moves gently onward. Rest now in that gentle vastness, in the steady turning of distant stars, in the soft glow of a galaxy 200,000 light-years wide, and let sleep come slowly, like light traveling across space, patient and unhurried, wide, quiet, steady. Andromeda continues, calm and immense, while you drift peacefully into rest. Andromeda continues, calm and immense, while you drift peacefully into rest. Now, as the quiet settles even deeper, we continue our gentle journey. Let us drift once more toward that faint glow in the night sky. From Earth, Andromeda appears small, a dim oval of light, barely visible without dark skies. It does not demand attention. It does not shine brightly like nearby stars. It simply rests there, subtle and steady. And yet, that soft glow spans a region of space so wide that even light needs 200,000 years to cross it. Imagine that width again. If you could stand at one far edge of Andromeda and look across its spiral to the opposite side, the distance would stretch beyond comprehension. Not miles, not billions of miles, but light years, hundreds of thousands of them. Within that immense span are stars separated by distances so great that each star feels solitary. Even in a galaxy containing perhaps 1 trillion stars, space itself is the most common feature. Space between stars, space between clusters, space within its halo. And this space is calm. It is not crowded. It is not compressed. It is open and gentle. If you were floating between 2 neighboring stars inside Andromeda, you might feel alone in the quiet. The nearest star could be trillions of kilometers away. The sky around you would be dark, punctuated by distant points of light. That is what makes a galaxy feel peaceful when imagined from within. Now imagine moving inward toward Andromeda's central region. The core glows more brightly. Stars gather more densely there, orbiting around a shared gravitational center. Their motion is slow and steady. They follow paths that take millions upon millions of years to complete. Nothing in a galaxy moves quickly on human timescales. If a star begins a journey around Andromeda's center, it may take hundreds of millions of years to return to its starting point. That is how slow a galaxy turns. That is how patient it is. And when we consider how big Andromeda is, we must also consider how long it takes for motion to unfold within it. Width and time are connected in space. 200,000 light-years across. 1 trillion stars. Millions of years for light to travel from it to us. Hundreds of millions of years for stars to orbit within it. It is vast not only in distance, but in duration. Now let us gently compare Andromeda to our own galaxy. The Milky Way, the galaxy that holds our sun, is about 100,000 light-years wide. That alone is enormous. If light started at one side of the Milky Way and traveled straight across, it would take 100,000 years to reach the other side. And Andromeda is roughly twice that width. Imagine placing the Milky Way next to Andromeda. The Milky Way would fit inside it, with room to spare. And yet, from Earth, Andromeda appears smaller than many of the stars we see. It softens scale. Distance makes even something immense feel gentle and contained. If Andromeda were closer to us, if it were as near as the moon, it would fill the entire sky. It would stretch from horizon to horizon, a vast luminous spiral arching overhead. But because it rests more than 2 million light-years away, it appears modest and quiet. That contrast is soothing. The largest things in existence can look small when viewed from afar. Perspective brings calm. Let us return to the number of stars it contains. Astronomers estimate that Andromeda may hold around 1 trillion stars. Some estimates are slightly lower, some slightly higher, but the idea remains the same. 1 trillion stars. If each star were a grain of sand, the total would form a beach stretching far beyond sight. If each star were a tiny drop of water, the total would fill vast oceans. And yet, each star is separated from its neighbors by enormous distances. Galaxies are not packed tightly like cities. They are more like wide landscapes with distant lights scattered across them. The spiral arms of Andromeda curve outward in long arcs. Within those arms are clusters of young stars, glowing softly. Between the arms are darker regions filled with dust and gas. And surrounding the bright disk is a faint halo of stars and globular clusters, extending even farther into space. So when we speak of its size, we speak of layers. A bright central region, spiral arms extending outward, a surrounding halo stretching even farther. Each layer adds to its width. Each layer adds to its quiet enormity. Now imagine drifting slowly above Andromeda, far enough away to see its full shape. From that vantage point, it appears as a vast spiral, a luminous disk with sweeping arms. Its center glows warmly, fading gradually toward the edges. The entire structure turns gently, so slowly that movement would be almost invisible in a single lifetime. You could watch it for centuries and see no noticeable change. That is how steady it is. That is how calm. Now imagine moving even farther away, so that Andromeda and the Milky Way both come into view. They appear as two great spirals suspended in darkness, each wide, each filled with stars, each turning slowly in the vast silence of space. Even here, Andromeda remains slightly larger, slightly wider, slightly more populated with stars, and yet still quiet, still serene. Its gravity binds its stars together across enormous distances. Even stars near the outer halo remain connected to the galaxy's center by invisible threads of gravitational pull. These threads stretch across tens of thousands of light years. They hold everything together in slow harmony. When we consider size, we often imagine solid objects, but a galaxy is mostly empty space. The stars are like scattered lanterns across a dark plain. If Andromeda were condensed into a solid object, its true scale would shrink dramatically. But that is not how galaxies exist. They are airy, spacious, open, and this openness is part of their calm. Now let us think again about its distance from Earth, 2.5 million light years. That means the light we see tonight left Andromeda long before modern humans existed. It traveled steadily across intergalactic space. The space between galaxies is even more empty than the space within them. Vast regions of near-complete darkness. And yet the light continued, uninterrupted, patient, until it reached our world. So when you see that faint glow in the sky, you are witnessing an ancient journey. You are seeing something enormous, softened by time and distance. Now imagine lying under a clear night sky, far from city lights. The air is cool. The stars are scattered across the darkness. Among them, Andromeda rests as a pale oval glow. You could almost miss it. But once you notice it, you realize that within that small blur are hundreds of billions, perhaps 1 trillion stars, all shining, all moving slowly, all contained within a region 200,000 light years wide. That thought can feel expansive, but instead of overwhelming, let it feel spacious. Let it feel like an open horizon, because in space, vastness is quiet. There are no sounds in the vacuum between stars, no wind, no rush, just motion unfolding slowly over millions of years. Andromeda continues its gentle rotation. Its stars continue their long orbits. Its light continues traveling outward in all directions. And here on Earth, we rest beneath it. Now let us revisit its width once more, slowly. 200,000 light-years. Imagine a beam of light beginning at the far edge of Andromeda's spiral. It travels inward, crossing star after star, sweeping past clusters and dust clouds. Year after year it continues. 1,000 years pass. 10,000 years pass. Still it travels. 100,000 years pass. It has only reached the middle. Another 100,000 years pass before it finally emerges at the opposite edge. That is how wide Andromeda is. Even light must be patient. Even light takes time. Now consider the number of stars again. If you could visit one star every second without pause, it would take more than 30,000 years to visit 1 trillion stars. That is longer than recorded human history. And yet, that is only a rough estimate of Andromeda's population. So when we ask how big Andromeda is, the answer is layered. It is wide in distance. It is vast in star count. It is deep in time. And it is gentle in appearance. The spiral arms stretch like calm brushstrokes across darkness. The halo surrounds the disk like a faint mist of distant lights. The core glows softly at the center, all of it turning slowly, all of it steady. Now imagine drifting inside one of its outer spiral arms. You are surrounded by stars, not close together, but scattered across the sky in all directions. Some shine brighter, some dimmer. Between them lies darkness. You feel suspended in open space. The nearest star is far away. The next, even farther. Even within a galaxy so immense, there is room to breathe, room to float, room for silence. Galaxies feel crowded only when seen from far away. Up close, they are spacious and calm. This is another way to understand Andromeda's size. It is not dense and packed. It is expansive and airy. Its stars occupy only a tiny fraction of its total volume. Most of it is emptiness, and that emptiness is peaceful. Now drift outward again, rising above the spiral arms. See the entire galaxy once more. A wide disk, curving arms, a glowing center, all suspended in blackness. 200,000 light-years from side to side, 1 trillion stars within, 2.5 million light-years from Earth, and still it rests quietly in our sky. The more we think about its size, the more it becomes a gentle reminder of perspective. On human scales, distances feel large. 1,000 kilometers can seem vast. But in space, even millions of kilometers are small. Planets orbit stars at distances measured in millions or billions of kilometers. Stars are separated by trillions of kilometers. Galaxies are separated by millions of light years. And within that scale, Andromeda is large. But it is part of something even larger. The universe contains billions of galaxies, each with their own width, each with their own stars, each moving slowly through space. And so Andromeda is immense, yet also one among many. That thought can feel steadying. Everything has context. Everything fits within something greater. Now return once more to the quiet glow in our sky, that faint oval shape, that soft blur of light. Within it are countless stars. Within it are spiral arms stretching across unimaginable distance. Within it are regions of calm emptiness. Within it is motion so slow it feels still. And yet, from here, it appears small and serene. The vastest structures in the universe often appear the gentlest from afar. And that is comforting. As you rest, let the idea of Andromeda's size become softer. 200,000 light-years wide, 1 trillion stars, millions of years of light travel, all steady, all calm. Imagine its stars continuing their slow dance around the center. Imagine its spiral arms turning gradually. Imagine its halo extending outward like a faint embrace. Nothing urgent, Nothing sharp, just quiet rotation. Andromeda has existed for billions of years, long before Earth formed, long before our sun began to shine. It will continue existing for billions more. Its motion is measured in epochs, not moments. And so, as you breathe slowly, imagine aligning with that steady pace. Slow, gentle, unhurried. The galaxy turns, the stars glow, light travels, and you rest beneath it all. Now, as we move toward the final quiet stretch of this journey, let the language become even softer. Andromeda is vast. It is wide beyond imagination. It holds more stars than we can count, yet it moves calmly. Its size does not make it loud. Its distance does not make it lonely. It simply exists, suspended in darkness, turning slowly, glowing gently. From Earth, it is a faint light. From within, it is a vast ocean of stars. From afar, it is a spiral brushstroke across space. Its motion is steady. Its scale is immense. Its presence is quiet. 200,000 light years, 1 trillion stars, 2.5 million light years away, and yet visible, and yet calm. Let that calm settle over you. Let the vastness feel open and spacious. Let the scale become soothing rather than overwhelming. Because in space, large things move slowly. Large things are patient. Large things endure. Andromeda continues its quiet rotation. Its stars continue shining. Its light continues traveling outward. And here on Earth, you rest beneath that same sky. The galaxy is wide. The night is still. Everything is steady. Drift now with that steadiness. Drift with the slow turning of distant stars. Drift with the gentle arc of spiral arms stretching across darkness. Wide, quiet, steady. Andromeda remains vast and calm, while you drift deeper into peaceful sleep. And as that quiet deepens, we continue. There is no rush to reach the end of this vastness. No need to hurry across it. We simply remain with it, gently exploring its size from another angle, another calm perspective. Imagine again the full span of Andromeda. 200,000 light years from one edge to the other. If we reduce that enormous distance into something smaller and easier to picture, we might imagine shrinking it down to the size of a continent on Earth. Even then, each star would be separated by distances equivalent to hundreds of kilometers, wide plains of darkness between scattered lights. But even that comparison is only a faint shadow of its true scale, because Andromeda is not flat like a continent. It has depth. Its disk is tens of thousands of light years thick in places. Its halo stretches far above and below the bright spiral, like a soft sphere surrounding it. So its size is not just width, but volume. A vast, three-dimensional ocean of stars. Now imagine slowly moving through that volume. You pass one star system, then long darkness, then another distant star. The time between encounters is long. Even traveling at unimaginable speed, the emptiness dominates. This is how a galaxy feels from within. Not crowded, not compressed, but open. If you were to place our entire solar system inside Andromeda, it would disappear within its scale. Our sun would be one among perhaps a trillion. Our planets would be far too small to notice against the background of so many distant suns. And yet, somewhere within Andromeda, there may be worlds circling other stars. Quiet planets in distant systems, orbiting slowly, bathed in the soft light of their own suns. And those suns would be only tiny points inside a spiral that stretches across 200,000 light years. Now let us think about how Andromeda holds itself together. Gravity extends across the entire galaxy. It binds the stars to the center, keeping them in orbit. Even stars near the outer edge feel that pull, faint but steady. Gravity works across unimaginable distances, across tens of thousands of light years. That is another way to understand its size. The invisible threads that hold it together stretch across the full width of the galaxy, from one far spiral arm to another, from the halo down to the bright core, all connected, all part of the same slow rotating structure. Now imagine standing still in space, watching Andromeda turn. It would not feel like spinning in the way a wheel spins. It would feel almost motionless. The change would be too gradual to notice. Only over millions of years would the spiral arms shift their positions. This slowness is part of its vastness. Small things move quickly. Large things move slowly. Andromeda is enormous, so its motion is gentle. Its turning is patient. Its stars trace vast circular paths around the center. A single orbit may take 200 million years. To put that into perspective, 200 million years ago on Earth, the world looked very different. Continents were arranged differently. Life was in another stage of its long journey. And yet, during all that time, a star in Andromeda may have completed just one orbit. That is the timescale of a galaxy. Now drift outward once more. Imagine seeing Andromeda not from above, but from the side. From this angle, its thin disk becomes clear. A long, flat band of light. The central bulge rises slightly thicker in the middle, glowing softly. The spiral arms wrap around the disk like gentle waves. The halo surrounds it all, extending much farther than the bright region alone. So when astronomers measure its size, they must decide where the galaxy truly ends. Is it where the bright spiral fades, or where the faint halo disappears into darkness? Even the boundary of a galaxy is not sharp. It fades gradually, light thinning into space, stars becoming fewer and farther, almost apart, until darkness takes over. This fading edge makes Andromeda feel even more spacious. There is no hard border, no wall, no abrupt ending, just a gentle thinning of light. Now imagine the journey of a photon, a tiny particle of light, leaving a star in Andromeda's outer arm. It begins traveling outward. It crosses thousands of light years inside its own galaxy. It leaves the disk and enters intergalactic space. Then it continues. For more than 2 million years, it travels through almost perfect emptiness. No sound, no friction, no interruption, just steady motion. And eventually, that photon reaches Earth. That is how far Andromeda is. That is how wide the gulf between galaxies can be. And yet, despite that immense distance, we see it. A faint glow, a reminder of something vast. Now let us return to its stark out again, gently, without urgency. 1 trillion stars. Even that number is uncertain, because counting stars in a distant galaxy is not simple. Astronomers estimate, based on brightness and mass and careful measurement, but whether the number is slightly less or slightly more, the truth remains. It contains more stars than we can comfortably imagine. If each star were a note in a piece of music, Andromeda would be a symphony too long to ever fully hear. If each star were a grain of sand, it would outnumber the grains on many beaches combined. Yet they are not clumped together tightly. They are spread across a disk 200,000 light-years wide. Space dominates. Darkness dominates. Light appears as scattered jewels against black velvet. Now imagine drifting through its central region. Here, the stars grow more numerous. The sky would appear brighter. The distances between stars slightly smaller, though still vast by human standards. The central bulge rises like a luminous dome, and at the very heart lies a supermassive black hole. Quiet, not dramatic, simply present, its gravity influencing nearby stars. But even here, in the densest region, there is space. There is room between stars. There is quiet between motions. And then, as you move outward again into the spiral arms, The density decreases. Stars spread farther apart. The sky darkens. Beyond the arms, the halo begins. Sparse stars orbiting at great distance. Some of those halo stars may travel tens of thousands of light years above or below the disk before curving back inward in their slow orbits. So Andromeda is not flat alone. It is layered. Disk, bulge, halo, all together forming a vast gravitational community. Now imagine shrinking Andromeda to a size that fits inside your imagination. If the entire galaxy were reduced to the size of a dinner plate, our solar system would be smaller than a speck of dust on its surface. That is how small we are compared to it. And yet, from Earth, it appears no larger than a small blur in the sky. Perspective softens immensity. Distance compresses scale. Now, picture standing on Earth again, beneath a dark and open sky. You look upward and find that faint glow. It does not appear threatening. It does not appear overwhelming. It is quiet. And that quietness is part of its comfort. The universe can be vast without being loud. It can be enormous without being dramatic. Andromeda is proof of that. 200,000 light-years wide, 1 trillion stars, 2.5 million light-years away, and still gentle. Now let your thoughts move slowly through time. Andromeda formed billions of years ago. In its early days, clouds of gas condensed under gravity, forming the first stars. Those stars lived their lives and faded. New stars formed in their place. Over billions of years, the spiral structure emerged. The arms wound gracefully around the center. All of this unfolded slowly. No hurry, no rush. Galactic time flows differently from human time. Where we measure in days and years, galaxies measure in millions and billions of years. That difference itself speaks of size. Because when something is enormous, change comes slowly. Now imagine drifting far beyond both Andromeda and the Milky Way. You see them as two spirals separated by dark space. Around them are many other galaxies, each at their own distances, each wide in their own way. Some smaller, some larger, all suspended in the vast cosmic web. In that larger picture, Andromeda is one of many. But from our position, it is the nearest large spiral galaxy, our closest galactic neighbor, close in cosmic terms, still incredibly distant in human terms, and so it becomes a gentle landmark in the sky, a reminder of scale, a reminder of distance, a reminder that vast things can appear small. Now, let the repetition of its size become like a quiet lullaby. 200,000 light-years wide, 1 trillion stars, millions of years for its light to reach us. Slow rotation, vast emptiness between stars, faint glow in our sky, wide, quiet, steady. As you continue to relax, imagine floating just above one of its spiral arms. Stars drift beneath, you each following its own slow path. The arm itself curves gently around the center. Dust lanes trace dark lines through the glow. Beyond the arm lies more darkness, then another arm farther inward. The entire structure feels like a soft whirlpool of light, but not spinning quickly, turning so gradually that stillness and motion feel almost the same. Now imagine moving outward to the very edge of its halo. The stars are sparse here, far apart. Some may take hundreds of millions of years to complete a single orbit. Beyond them lies intergalactic space, a dark, open expanse stretching millions of light years. Andromeda's gravitational influence slowly fades into that darkness. The boundary is not sharp. It is gradual, like twilight fading into night. Now let that image soften. Let the width of Andromeda become a gentle horizon, stretching far beyond sight, and yet contained within a single quiet structure. Its immensity does not overwhelm. It simply is, steady, enduring, calm and As you rest beneath the night sky, knowing that this vast galaxy hangs quietly in the distance, allow that knowledge to feel peaceful. The universe is wide. The distances are great. The timescales are long. And everything moves slowly. Andromeda continues its patient rotation. Its stars continue shining. Its light continues traveling. Nothing hurried, nothing abrupt, only the steady unfolding of cosmic time. Let that steadiness become your own rhythm. Slow breath in, slow breath out. Wide, quiet, steady. Andromeda remains immense and serene, a vast spiral of light turning gently in the darkness while you drift further into rest. And as the stillness continues to deepen, we keep drifting. There is no edge to this calm exploration, only another gentle widening of perspective. Imagine now that you are floating in the space between the Milky Way and Andromeda. The darkness around you is not empty in a harsh way. It is soft. It is open. It feels like an endless night sky in every direction. Ahead of you, Andromeda stretches wide. Even from this vantage point, still millions of light years away, its spiral shape is clear. A broad disk of pale light, arms curving outward in long, graceful arcs. It does not flicker. It does not pulse. It simply glows. Its size becomes clearer as you approach, though the approach is slow. The galaxy does not suddenly loom. It gradually grows in your view, like a distant mountain range appearing larger as you move closer. Though here the scale is measured in light years instead of miles. 200,000 light years wide. Let that number return again, softly. 200,000 years for light to cross from one side to the other. If a star were born at one edge of Andromeda and its light traveled toward the opposite side, that light would journey for 200,000 years before arriving. That is how wide the galaxy is from edge to edge. And within that width, the spiral arms wrap inward toward the center, forming a vast pattern that repeats itself in quiet symmetry. Now imagine gently passing through the outer halo. The halo is faint. The stars here are scattered, sometimes traveling in elongated paths that carry them far above the main disk before returning. Some globular clusters drift here too, compact gatherings of ancient stars bound tightly together, orbiting the galaxy's center from great distances. The halo stretches far beyond the bright spiral. It extends outward like a faint sphere of distant light, gradually thinning into darkness. So Andromeda's size is not just the bright spiral we often see in images. It includes this extended halo. Its full gravitational presence spreads even farther. As you drift inward toward the disk, the stars slowly become more numerous, still separated by vast emptiness, but appearing more frequently against the darkness. The spiral arms begin to take shape around you. They are not solid structures. They are regions where stars are slightly more concentrated, tracing curved pathways around the center. Within these arms are clouds of gas and dust, slowly forming new stars over millions of years. Everything unfolds at a calm pace. Even the birth of stars is not sudden on cosmic timescales. It happens gradually, over spans of time that stretch far beyond human memory. Now imagine that you pause inside one of these spiral arms. You are surrounded by stars, each separated by trillions of kilometers. If you turned slowly in place, you would see distant suns in every direction. The nearest might be several light years away. The next, farther still. Though Andromeda holds 1 trillion stars, the space between them remains dominant. Space is the most common ingredient of a galaxy, and that space is peaceful. There is no sound in this vacuum. No wind, no echo. Only the quiet light of distant suns. Now gently move toward the center. The central bulge rises gradually, becoming brighter as you approach. Here, the density of stars increases. They are still far apart by human standards, but more closely spaced compared to the outer arms. The core glows with a soft intensity. At its very heart lies a supermassive black hole, millions of times the mass of our Sun. It rests there quietly, influencing the stars that orbit near it. There is no need to imagine drama here. It is simply part of the structure, a central anchor holding the inner stars in their slow, circular paths. The stars near the center move more quickly than those in the outer regions, but even their motion unfolds over millions of years. A star near the core might complete an orbit in tens of millions of years. A star farther out might take hundreds of millions. The farther you go from the center, the longer the journey around it becomes. This gradual change in motion across the galaxy is another reflection of its immense scale. Now imagine drifting outward again, rising above the disk so that the entire galaxy lies beneath you. From this angle, Andromeda appears like a luminous whirlpool set against black velvet. Its arms curve with quiet elegance. Dark lanes of dust trace subtle patterns within the glow. The center shines steadily, and the outer halo surrounds it all like a faint mist of distant light. 200,000 light-years across, 1 trillion stars within, a halo extending even farther. Now let us gently revisit the idea of how it appears from Earth. On a clear, dark night, far from city lights, Andromeda can be seen with the naked eye. It appears as a faint, elongated patch of light, not bright, not sharp, just a soft smudge. And yet, that smudge spans a region of space larger than our own galaxy. If we could see its full extent clearly with our eyes alone, it would appear much larger in the sky than the moon. But most of its light is too faint to perceive without telescopes. So what we see is only its brightest core. Its outer arms and halo remain hidden to casual view. This is another gentle reminder of perspective. What appears small and faint may in truth be vast beyond measure. Distance dims brightness, distance compresses size, and so Andromeda's enormity becomes a quiet glow. Now imagine placing Earth somewhere within Andromeda. Nothing dramatic would change in how it feels locally. You would still see stars in the night sky. Perhaps the sky would appear slightly more crowded, depending on your location within the galaxy. But even then, the distances between stars would remain immense. Galaxies are not packed like clusters of marbles. They are wide, open systems. If our solar system were inside one of Andromeda's spiral arms, it would blend seamlessly into the pattern. Our Sun would orbit the galaxy's center, just like countless other stars, completing one orbit in hundreds of millions of years. Slow, steady. Now imagine shrinking the entire galaxy into a model small enough to hold in your hands. If Andromeda were reduced to the size of a coin, each star would be far too tiny to see with the naked eye. They would be microscopic specks scattered across the surface, and most of the coin would be empty space. This model helps us understand how galaxies can be so large yet so sparse. Now let us think about its mass. All those stars combined create a gravitational presence that extends far beyond the visible light. There is also dark matter, an invisible component that adds to the galaxy's total mass, helping hold it together. Though unseen, it contributes to the galaxy's size and structure. Its gravitational influence reaches tens of thousands of light-years beyond the bright disk. So when we speak of Andromeda's size, we are speaking not only of its visible light, but of its full gravitational reach, a vast sphere of influence extending into space. Now imagine drifting far beyond Andromeda once more. You look back and see it as one luminous spiral among many. Other galaxies surround it at various distances, each glowing faintly in the darkness. The universe itself stretches outward beyond sight. Andromeda is immense, yet part of a greater whole. That thought can feel grounding. Everything belongs to a larger pattern. Everything fits within a wider context. Now let us gently revisit its width once again. 200,000 light years. Let that number feel less like a calculation and more like a horizon. A horizon so distant that even light must travel for 200 millennia to cross it. Imagine a beam of light starting at the outer edge of a spiral arm. Year after year, century after century, it travels. 10,000 years pass. 50,000 years pass. 100,000 years pass. Still, it has not reached the far side. Finally, after 200,000 years, it emerges at the opposite edge. That is the span of Andromeda, and within that span are 1 trillion stars, each following its own quiet path, each glowing with its own light, each separated by vast emptiness. Now imagine lying once more beneath the night sky on Earth. The stars above you seem countless, but most of what you see belongs to our own galaxy, and beyond them, faint and subtle, is Andromeda. A separate galaxy, a separate island of stars, visible as a gentle blur. It does not appear large, it does not appear imposing, it is quiet. That quietness makes its vastness feel peaceful. The universe is not crowded with noise, it is filled with slow, steady motion. Now allow the repetition of scale to become even softer. 200,000 light years wide, 1 trillion stars, 2.5 million light years away. Slow rotation over hundreds of millions of years. Faint glow in the sky. Wide, quiet, steady. As your thoughts drift, imagine Andromeda turning almost imperceptibly, its spiral arms slowly shifting, its stars tracing vast arcs, its halo stretching outward into darkness. Time flows differently there. Change is subtle. Motion is patient. The galaxy does not hurry. It does not rush toward completion. It simply continues. Billions of years behind it. Billions ahead. And in that long arc of existence, human time is brief. Yet tonight, you share the same universe. You share the same starlight. The photons from Andromeda that reach your eyes have crossed unimaginable distances. They began their journey long before any human looked up at the sky, and yet they arrive quietly, gently, without sound. Now let the scale become softer still. Imagine Andromeda as a vast lantern floating in a dark sea. Its light spreads outward in all directions. It does not strain. It does not flicker wildly. It shines steadily, and that steady shining continues across millions of years. Now, as the rhythm of these thoughts becomes slower, let the language shorten slightly. Wide galaxy, slow turning, endless space between stars, ancient light crossing darkness, quiet spiral arms, soft central glow, faint halo, all suspended in silence. You do not need to picture every detail now. Just the feeling of vastness, open space, gentle motion. Andromeda remains immense, yet calm. Its size stretches beyond imagination, yet it appears small and distant. That contrast is soothing. Large and quiet, far and visible, vast and gentle. Now let the final stretch of this journey unfold even more softly. Imagine Andromeda resting in space. No urgency, no sharp edges. Just a wide spiral turning slowly in the dark. Its stars glow, its arms curve, its halo fades into night. 200,000 light years across, 1 trillion stars, millions of years of traveling light, all steady, all calm. The universe holds such vast structures without strain. It allows them to turn slowly, quietly, endlessly. And as you drift towards sleep, you can borrow that steadiness, that patience, that quiet endurance. The galaxy turns, the light travels. The darkness remains peaceful, wide, still, steady. Andromeda continues its slow rotation in the distance, immense and serene, while you drift gently into deeper and deeper rest. Andromeda remains far away, resting quietly in the dark, Yet it is immense beyond ordinary imagination. It stretches across space for about 200,000 light-years, a width so great that even light would need 200,000 years to cross from one side to the other. Within that wide spiral, there may be around 1 trillion stars, each one separated from the next by deep, open space. Most of Andromeda is not crowded or tight. It is calm, spacious, and still. From Earth, it looks like a faint, gentle glow, softened by distance. Its light has traveled for millions of years to reach us, moving steadily through the silent ocean between galaxies. And even with all that distance and all that size, Andromeda does not feel hurried. Its motion is slow. Its turning is patient. Its structure holds together in quiet balance, continuing on in steady rhythms that unfold over ages. So the thought of Andromeda can be simple and soothing. A vast spiral of starlight, wide and enduring, drifting calmly through space. Ancient, steady, and untroubled. And while it continues in its gentle way, you can rest in the same calm universe, letting the quiet scale of it all soften your mind and ease you into sleep.